Okay, so let me change my settings. I'll do this for a while. Share my screen. Okay, I think we have like a solid minute before we get started. Let's see. Yeah, minute and 10 seconds. I guess if anyone has questions, now is a good time to ask them before we get started. Again, we got about a minute. So if you have questions, now is a good time. Nope, not Teams, not Teams. Okay, we got 30 seconds. Well, let's see. 15 seconds and counting. All right, let's see. Okay, I think that's correct. Let's do as a single page. All right, gentlemen, let's see. So we will be wrapping what is this chapter? This here. Let me just kind of glance real quick. So we have we only have 3 sections remaining. Today we're going to be working on section 4.4. Yeah, we only have 3 sections remaining. So we'll do 4.4 today, 4.5 on Monday, 4.6 on Wednesday, and then exam 2 should become available not this Sunday, but next Sunday. For 7 days, you can earn full credit, right? Past the due date. You can still submit it, but there's a 5% late penalty. So if you submit any assignment late, the highest you can earn is 95%, which I think is still reasonable, fair. More than reasonable, right? Because it's late. Like, many professors, if it's late, they can be like, tough luck, right? So I feel like 95% credit is, or the potential for 95% credit is good. Give me just a moment. I'll be right back. Oh, sorry, come on. I totally forgot you were in here. Oh my goodness. Dog has been such a good girl. So we had somebody come by to look at the AC unit. And and so, kind of going around or whatever. And fast forward, I don't know how much time. So class started, and I'm sitting here, and I'm like, why is the light on in the bathroom? I was like, why did I leave that light on? I was like, let me go turn that off. And then as soon as I opened the door, I was like, oh, I forgot I put the dog in there when the guy came. So she's free now to roam about the cabin. Okay. But yeah, we're in the home stretch, right? So this is a great time to get caught up on assignments if you're just missing anything that's critical, right? The items that are critical are, now we've only had one exam, right? We had exam 1, so we're about to have exam 2. Exam 2 will cover chapters 3 and 4. It should become available not this Sunday, but next Sunday. For the first 7 days, you can earn up to 100%, and then past the due date, the highest you can earn is a 95%. Unlimited attempts. The system is set to take your highest score. It's pretty much like exam 1. It just covers chapters 3 and 4. So after next week, we'll just be reviewing, kind of trying to get ready for the finals. The finals is going to be cumulative. Mathematics by default generally is cumulative. I can ask questions from chapters 3 and 4, and it's built upon concepts from chapters 1 and 2. Yeah, again, this is a good time to get caught up. If you are going back and submitting old assignments to get caught up, the order of priority, you want to prioritize exams first. That's where you're going to get the most bang for your buck. And then you want to prioritize homework last, because that's going to be a lot of work from minimal points, right? again, that the intent of the homework is really there for practice and for you to receive some credit, but it's really practice to get you ready for the exams. Okay. And a good study guide for our final, I think, are the old exams. So like if you just practice exam 1 and exam 2, the final is basically a mix of those two, right? Unlimited attempts, let me think. When did I schedule the final for? I think, okay, so usually what I do for the final for this type of course, I make it available for the entire week of finals. Usually it's like from that Monday to that Friday. So that week of finals, that Friday is the hard deadline for all assignments, right? So be cognizant of that. So even though all of our assignments have a soft deadline, the hard deadline is that Friday at the end of finals, right? So we'll start reviewing for that in about 2 weeks. As usual, if you have questions, feel free to unmute yourself to get my attention and we can talk about it. Let me kind of check on you guys real quick. Okay, I'm glad I checked. I forgot to log in, but that's fine. I do need channel. I realize that I just need to kind of go through all my lives and like organize them, but they are grouped in the live sections, but you know, in the live tab or whatever. Anywho, all right, let's see. So let's go ahead and move into the section for today. So we're continuing chapter 4 in integration, and we're going to be working on section 4.4, properties of definite integrals, additive property, average value, and moving averages. So just another application of the integral. And again, integration is the reverse of differentiation. You know, originally we had a function, we took the derivative, we explored what it meant. Now we're starting with those answers, and through integration techniques, we're working backwards, okay? So definite integrals, additive property, average value, and moving averages, okay? So a few objectives here. 1, use the properties of definite integrals to find the area between curves. 2, solve applied problems involving definite integrals. 3, determine the average value of a function. And 4, find the moving average of a function. Okay, we should be able to do this. So for A strictly less than B, strictly less than C, the integral from A to C of f of x dx, notice that the B is between A and C. So we can break the integral up into the integral from A to B f of x dx plus the integral from B to C f of x dx, all right? So we have a B that's between A and C, and we go to take the integral from A to C, we can break it up into 2 separate integrals in this fashion. So for any number B between A and C, the integral from A to C is going to be the integral from A to B plus the integral from B to C. Okay, let's keep going. So find the area on the graph, find the area under the graph of f. Let me see. Okay, from -4 to 5, we have a piecewise function, right? So f of x is 9 when x is strictly less than 3, and it's x squared when x is greater than or equal to 3, right? So basically what we're going to do is break this shape up into break this image up into its basic shapes, and then find use integral or find the area under the curve of each basic shape, right? So the piecewise function, you know, I don't know, the number that it's kind of focused on is when x is 3, right? So we'll break this up into the integral as x goes from -4 to 3, right? And we'll calculate that integral. Then we're going to say plus the integral as x goes from 3 to 5, okay? Right, this is pretty much a repeat of what we did last time. Once you break it up into the simple shapes, right? Okay. So essentially what we're doing, we're saying the integral as x goes from -4 to 3. Now, if we're left of 3, we're going to use that first line. So it's going to be 9 dx plus the integral as x goes from 3 to 5 of x squared dx. Okay. So the integral of 9 should be what, 9x? And we want to evaluate that as x goes from -4 to 3. Okay. Then we're going to say plus The integral of x squared is what? X cubed over 3? We want to evaluate that as x goes from 3 to 5. Okay. So then ultimately, let me see. So we're going to have like what? 27 minus 36. That's okay. Plus, it looks like a 125 over 3. Minus 9, right? If it's 3 cubed over 3, it's really 3 squared, so that's 9. Let's see. That's an 8. Okay, I'm going to use Siri. Siri, what's 27 minus 36 plus 125 divided by 3 minus 9?
27 minus 36 plus 125 divided by 3 minus 9 is approximately 23.6666.
I don't know why I didn't think of changing it within this earlier. Like that totally makes things so much easier for me. Let me copy this. So we got that the area under the curve is 23.6 bar. Let's see. Oh, maybe not. Did we make a mistake? Let's see. Let's see. So it should be 3 plus, oh, yeah, double negative. Right here. It's supposed to be minus, so it's a double negative. This is really supposed to be plus here. Right here. That's supposed to be a plus. Okay. So let's just confirm the number. Let me get rid of this and that. Siri, what's 27 plus 36 plus 125 divided by 3 minus 9?
27 plus 36 plus 125 divided by 3 minus 9 is approximately 95.6666.
Okay. All right, I think that's what they got. Yeah. So yeah, we missed a double negative. One little sign and it's everything goes sideways, right? But you know, that's part of the challenge. I leave this as an exercise for you. Okay. So let f and g be continuous functions and suppose that f of x is greater than g of x over a closed interval ab. Then the area of the region between the two curves as x goes from a to b is going to be the integral as x goes from a to b of f of x minus g of x dx, right? So in this one, we are considering, we want to find the area between two curves, right? So you're looking for this thing. Now, what is that? Is that a zoom? That is zoom. I don't want that. Thank you. Right, so notice that f of x is greater than or equal to g of x, right? So then we want if we want the area between f and g, we would take the integral as x goes from a to b of f minus g. Okay, and that'll give us the area between the two curves. Okay, so let's see. Okay, so find, just want to make sure it's not worked out. Okay, find the area of the region that is bounded by the graphs. So if we're going to evaluate it as x goes from what? 0 to 2, as x goes from 0 to 2 in that region, notice that f is greater than or equal to g as x goes from 0 to 2, right? I kind of need to give myself some space, but I'm going to kind of work here. I think it'll be okay. So we're evaluating the integral as x goes from where 0 to 2. We're basically saying f of x minus g of x. I'm just going to go ahead and write that. So it should be 2x plus 1. Now we got to be cognizant. We got to distribute a negative into g of x. So it's going to be minus x squared minus 1 dx. Okay. That's going to be what? Minus 2. Okay, I think we can just go ahead and take the integral. I'll work here. And I'll put it in descending power order. The integral of x squared is what? X cubed over 3. So that's going to be a negative x cubed over 3. The integral of 2x is what? 2x squared over 2. So it's just x squared. So plus x squared. And the integral, oh, those cancel, right? We have a plus 1 and a minus 1, so they cancel each other. And we want to evaluate this guy as x goes from 0 to 2. Okay. I know it's a little bit, if I need more space, I'll make some more space. So then we plug in when x is 2 minus, well, when x is 0, it looks like it's 0. So it should just be, when we plug in 2, that should be our result, all right? So that's going to be like a negative 2 cubed over 3 plus 2 squared. So that's a negative 8 over 3 plus 4. 4 over 1 is 12 over 3. So what is that? 4 over 3. Okay. So hopefully that made sense. Copy. We're going to check on the next slide for accuracy. Let's see. Okay, 4 over 3 is correct, right? So hopefully that was okay and it made sense. Again, if anything is not clear, just get my attention and we can talk about it. I'm checking you guys in Zoom. You guys look good. Should be check my attendance. Are we missing somebody? How'd that happen? It's okay. I'm not going to make a big deal. All right. So we got that one correct. Let's keep going. Okay. All right. So let's look at this. It says that a clever college student develops an engine that is believed to meet all state standards for emission control. The new engine's rate of emission is given by this guy, where E of T is the emissions in billions of pollution particulates per year. It feels like a tongue twister. Pollution particulates per year. Peter Piper picked a peck of pickled peppers. If Peter Piper picked a peck of pickled peppers, how many pickled peppers did Peter Piper pick? Anyway, that's what it sounds like to me. Billions of pollution particulates per year at time t in years. The emission rate of a conventional engine is given by this. Let me see. The new engines is this. Okay. The emission rate of a conventional engine is given by this. Probably want the area between the curves or something. The graph of both curves are shown to the right. For part A, at what point in time will the emissions rate be the same, right? So we want that point of intersection. So we'll find that. We'll just set the two equal to each other. I'm going to need to give myself some space. And then for B, what is the reduction in emissions resulting from using? Is that the area under the curve? Is there a C? No. Okay. I think they should be asking for the area under the curve. So that's, yeah, we'll just do that. So the point of intersection, where do these guys meet? So basically we set the two equations equal to each other. I guess I'll go ahead and do this on this slide. So if we have what? 2t squared equals 9 plus t squared. Okay. If we set this to 0, we're going to have what? T squared minus 9 equals 0. So t is plus or minus 3. And I think that the negative 3 doesn't make sense in our context, right? Yeah, so negative 3 doesn't make sense. So that's giving us when t is equal to 3. So when t is 3, do we need the y? I don't think we need the y. If we do need it, we'll find it. Okay. So for A, At what point in time? After three years of use. Hopefully you all were able to get out and enjoy some of this beautiful weather today. It was like kind of trippy because like if the wind blew and or if you were like standing in the shade, it was like cold, but then as soon as you step in the sun, it was warm. So I really enjoy like that contrast. Like it just, I don't know, it feels good. Let's see. So I think what they're asking for is the integral as t goes from 0 to 3. And we're going to say c of t minus e of t. So 9 plus t, we're going to say 9 plus t squared minus 2t squared. So that's c of t minus e of t. Let me cut this guy. I'm going to drop it here. And we need to put dt. Okay. Let me do this. Just going to move this over just a little bit. So this is going to be equal to the integral as t goes from 0 to 3. Negative, so 9 minus t squared dt. Okay. So then if we integrate, that's going to become what? 9t minus t cubed over 3. And we want to evaluate this as t goes from 0 to 3. Okay, so it should just be when we plug in 3, because when we plug in 0, we get 0. So when we plug in 3, that's what? 27 minus 9 is what? 18? Yeah. Oops. Let's see. After 3 years, so the reduction in emission is represented by the area between the graphs, E of t and C of t, as t goes from 0 to 3. So then we got 18 billion pollution particulates per year, right? So what we did was correct. Okay, we're already halfway through this section. All right, we have this definition. So let f be a continuous function over a closed interval AB. The average value over the closed interval AB is given by 1 over b minus a times the interval. Okay, so we got a continuous function over a closed interval. The average value over that closed interval is given by 1 over b minus a, right? So when we go to find the average value, we're taking the integral like normal. We just have to multiply the outside of it by 1 over b minus a. Let me take. Taking that distance. Okay, that's fine. Let's keep going. All right, hang on. Give me a second. I'll give it one more, because sometimes you guys are changing devices and you come back. I like to know when you're in the waiting room. Like if it were up to me, I just want to know you guys show up so I can log it. When you guys leave, it always distracts me, but it's not a big deal. Not right now, and not at the rate we've been doing it. You know, if it gets excessive, that's another reality. Find the average value of this function over the interval from 0 to 2. Okay, that's not too bad, right? So y average should be 1 over 2 minus 0 times the integral as x goes from 0 to 2 of x squared dx, right? That's it. It's just a regular integral with that coefficient, right? Okay. So then that's going to be a half times, that's going to be what? X cubed over 3. And we want to evaluate that as x goes from 0 to 2. Okay, so that's a half times 8 over 3. That's it. So then the 2 turns to 8 and 2 or 4. That's exactly why I didn't turn it off, because I felt like, let me make sure I got his credit. go ahead and mark everybody else as absent. And where are you guys? Is there something? Am I missing something? Where's everybody? Okay, so the 2 turns an 8 into a 4. It looks like we finished with 4 over 3. Okay. Yeah, that's not too bad. So 4 over 3 is correct. Okay. Okay, drugs are bad. Okay. When I'm saying excessive okays, that's what's in the back of my mind. Drugs are bad. Okay. Just so you know. I have not seen that show in like eons. I had some good times with that show. Sometimes like one of the hardest laughs I ever had with that show was the episode when Kyle got a Black American Express card, like credit card. And so, the economy was failing, and Kyle was like, I think I have an idea, guys. And his mom found out, was like, Kyle, what are you doing? No, don't do that. He was like basically he was gonna pay for everybody's debts, put it on his credit card that had unlimited credit limit. His mom was like, no, you'll be in debt forever. And by the time he finished swiping it, he like passed out on his back, and like the townspeople hoisted him up like a martyr, like Jesus. He was like, no, he paid for everybody's debts. It was so silly. That one, and like what's his name? When they had Kanye on there, they just had some classic moments anyway. So Mr. Mackey. Anywho, just silly things. Okay. So Rico's speed in miles per hour 2 minutes after entering the freeway is given by this guy, right? Okay, so that's the speed. The time is what? Less than or equals, is that 30 minutes? Yeah. From 5 minutes after entering the freeway to 25 minutes, what was Rico's average speed, right? So Y average, like we did in the previous. How far did he travel over that time interval? So if you take the derivative, let me think. The derivative of that should be that, and yeah. Are we taking the derivative? I think so. Anyway. Okay, so from 5 minutes after entering the freeway to 25 minutes, what was his average speed? So that's Y average. I'm just going to work with the space here. All right. So it should be 1 over, it says 5 to 25. So we're going to say 25 minus 5 times the integral as x goes from 5 to 25 of this guy. I'm just going to shorten it by v of t, whereas t goes from, dt, right? Because I just don't have the space, right? So we're going to integrate v of t. I think I can get it here. That's a 1 over 20. Okay. Okay. So that becomes what? T to the 4 over 4. So let's see. Negative t to, nope. T to the 4. Let me see. It's over 800 is the first one. T cubed over 3. So it should be t cubed over 20. Okay. T squared over 2. Okay. So 3t squared over 16. Okay. Plus 60t. We want to evaluate this as t goes from 5 to 25. Okay. I think I might just put the whole thing in my calculator. Because I'm just being a little bit lazy. 625. Trying to see if I can get some of this to come down some. Okay. So if we plug everything in, the coefficient should be 1 over 20, right? I'm going to do a square bracket. The first one, when we plug in 25, we'll get a negative 25 to the power of 4. That's massive. Over 800 plus 25 to the power of 3 over 20 minus 3 times 25 squared over 16 plus 60 times 25. Now, something like this, you'd definitely be better off writing with plenty of space, not trying to jam it in like I do, because when you write small like this, it's easy to lose track. I should, have a blank page and write it like that. And then we're going to plug in when t is 5. So we're going to have a negative 5 to the power of 4 over 800 plus 5 cubed over 20 minus 3 times 5 squared over 16. 300, I think that is. Okay, that's about the best I could do. I am tempted to just put it in the calculator like that. Right, it's kind of long. We probably could simplify some stuff down, but I feel like that's about the capacity of what I can do when it comes to this in this moment. So let's start here, right here. And what I'm gonna do, there we go. If you have a subscription to Max, I did just watch that series, the mini docu-series, Quiet on the Set. Man, that thing was intense. Fair warning though, trigger warning if you do decide to watch it. Like, it's some heavy topics, but man, it was, I had no idea all that. I mean, it makes sense as an adult when I think about it, but as a youth, watching those shows, I was oblivious. Right, I was just like, man, it was heavy. But if you can watch it, I do recommend it. Okay, let me think one other thing. Okay, I'm tempted to do something, right? I'm going to try something that I think we did last time. Y equals, if I can get this to work. I'm going to put the original in. Negative 1, let's do parentheses. Actually, it's not necessary. We'll say t cubed over 200, so x to the power of 3. It should be okay. Over 200. I think that's okay. Yeah, it should be. Plus 3x squared over 20. Okay. Minus 3x over 8. Okay. Plus 60. Right? That's the original. Wait a minute. What's this? The y average. Okay. Okay. So we have the original, right? So what I'm going to do, 1 over, I guess you can just do 20, that's fine. No, let me just do 25 minus 5, right? Let me see if I go to math, number 8, derivative number 9, right? So we're taking the integral, let's call it our function, with respect to x. And we want to evaluate this as x goes from 5 to 25. Okay. All right. I think this is okay. Because we have that coefficient, 1 over 20. I could put times. Let me see if it works. We got a result. So, I mean, I just didn't feel like typing all that out. I was like, okay, I think we can put the original in. I'll just say it continues here. We got 68.75 miles per hour. Oh, wait a minute. Everything in the freeway is given by this. In miles per hour, okay. Mm-hmm. What was Rico? Okay, yeah, I think we can put miles per hour, right? Okay, let's see how do we do. This. think he was here. Yeah, he came and left. That's fine. Okay. We got the 68 point, and that's reasonable. About 69 miles per hour, almost 70. His average speed. Okay, let's see. Woohoo, we got it. Right. So, I mean, like you can see, they calculated the numbers individually. Right. Oh, come on. Right. They got this result minus this result. The technique I did, I just put the original in. Right. I put this guy in. Right. Into my, what is this, a TI-83. Now, I mean, if you write it out, this is what you have to crunch. I just didn't feel like fooling with all of that. All right. So I was like, okay, well, I know this is the work, right? And then if that's correct, basically I just put this into the calculator, evaluated it as X goes from 5 to 25, and then times this coefficient for the average value. Okay. Not too terribly bad. I thought it was interesting to use the calculator for something like that. Okay. All right, so we got it. Miles per hour. Let me see. How far did he travel over that time interval? So another thing that he might do, if that's his average speed, and he's traveling for what, 20 minutes? So we would say that times 20. Is that correct? Let's see if that times 20 works. Okay, so we'll say that answer times 20. Wait a minute, that's miles per hour. If it's 20 minutes, that's what, a third of an hour? So times 1/3? Because you have to have the same units. So almost 23 miles, approximately 23 miles. Yeah, yep, we got it. Oh, okay. So if I hit 68.75, no, this is fine. What we have is fine. We can get that fraction, right? So like if we say minus 22, like that, and then we hit math as a fraction, 11 over 22, right? So again, part of the thing was like, again, we had his average speed, and he traveled for 20 minutes. I almost multiplied by 20, but I was like, wait a minute. His speed is in the units of miles per hour, and we want 20 minutes. So they need to have the same units. So we had to convert minutes to hours. 20 minutes was a third of an hour. So then we said a third times his average speed to give him 22 and 11/12 of a mile. Okay. All right, I think we're okay. This is an exercise for you all. Let's look at this definition. So let f be a continuous function over a closed interval AB. The moving average function of f is given by this, moving average. Let's see. So we have the average value, that was y average. The moving average was f average, like this little f sub average. And now what is L? Where L is a constant representing a fixed interval of time. Okay, x to the, let me see, 1 over L times the integral as x goes from x to x plus L, f of t dt. Okay, give me just a moment. Okay. And L is a constant representing a fixed interval of time. Okay, let's give it a go. So we have, this is on business with moving averages. The weekly revenue in thousands of dollars of trucks, rentals, X weeks since the start of the year is given by this, where X is greater than or equal to 0, but less than or equal to 10. Find the moving average over the 3-week interval. Oh no, I didn't want this to show. Okay. A fixed period of time, right? So for the first average, right? So L is what, a 3-week time span. So L is 3. And for the first moving average, we start when X is 0, right? And I'm just going to kind of piggyback off what we have here, right? So again, L is the fixed period of time. So it said for 3 weeks over 3-week intervals. So the first moving average starts when X is 0 and then 0 plus 3. and then R of t dt. So we're going to be using this guy. Right. So you know how to calculate this. You saw where we just did something like this in the calculator. We can put this in the calculator to calculate the interval, evaluate it as t goes from 0 to 3, and then times a third, right? We're going to get a result. Then now we move up by 1. So, when we start at 0, it gives us a sense of the next 3 weeks. The next moving average, we're going to start when x is 1. I think everything stays the same, but instead of x starting at 0, x is going to be 1 for the next moving average, right? So we know how to calculate. We know how to crunch this number, right? Right. So I'm just going to kind of, in good faith, leave that there. So over the first 3 weeks of the year, Trucks Rentals had an average revenue of $16,910 per week, right? So that's the first moving average. Let's look at the second one, right? So the second moving average, which is a 1, right? Everything is the same. The only thing that's changed is x starts at 1 instead of starting at 0, right? But everything else is the same. Okay. Let me think. Okay. So we can actually let's do this real quick. We're going to find a quick way to kind of represent this in this calculator. And again, I feel like once you get to the part here, hang on. Once you get to that part at the end here, once you're able to get to this, then it's kind of that same thing over and over and over, right? So it can be, that's why it's like being able to do something quick like this is helpful. If not, otherwise you're going to have to write this out, crunch numbers. It's a lot of extra work, right? So let's see if we should be able to get this, right? Let me think. Yeah. So let's put our vex in there. Let me see. We have this 0.05 x to the power of 4 minus 1.2 x to the power of 3 plus 9.6 x squared, okay, minus 28.6 x plus 38.3, okay. I feel like we typed it in okay. I don't see any major errors. So then we're just gonna call on the integral function. So if I hit math, and I think it's number 9 for the integral function. So number 9, I want to call in that function that we just typed in. We're gonna do this. Let me see. We said the integral, so we said 1/3 times this integral. So I'm inserting a 1/3 in front of it. We want to evaluate this integral of this function in terms of x. I'm just going to put x for our purposes. And we want to evaluate it as x goes. Now for the first one is this x goes from 0 to 3. And I think this will work. 0 to 3. Okay. And then close off the integral. Okay. If we did it properly, we should get 16.91. Okay. I accidentally hit it twice. Let me just do like this. Matter of fact, I'm gonna clear like this. No. Oh no. Oh, no. I don't know how to let me see. Yes. I think that's correct. Okay. Whew. All right. So I had an average revenue of this. So then now that's the average revenue of the first, let me see. X. Find the moving averages. So that was like the initial moving average. So then the next one's like the first moving average, right? So then here. So I think everything is the same, but instead of going from 0 to 3, now we're going from 1 to 4, right? So I'm just going to recall this and just change this from 1, 4. And then we should get 11.91, right? Then the next moving average is going to go from, what, 2 to 5, right? You have to kind of keep going, right? So as x goes from 2, 5, right? So for the next 3 weeks, 12.41. Yep, we got that one. And then 3 to 6, right? You see how like it's if you were doing this manually, it would be extensive or exhaustive or whatever. It's tedious. But since we can calculate the whole thing in an instant, then we can produce all these numbers in a reasonable amount of time. All right, 4 to 7. So 4 comma 7, right? And so, right, 4 to 7, and we just keep going until the final one is going to be 7 to 10, right? But you get the gist of it. So once we were able to do that, then you see how we generate each one of them. And again, so like when we considered that first one over these weeks, Trucks Rental had an average revenue of $11,910 per week. So moving average, right? So that was a showcase of moving averages. Okay. So we were able to generate the numbers. That was the main thing I wanted you to see there. The graph below displays R along with a graph of the moving average, R average, over these 7 3-week periods of time. The graph of the moving average retains the general shape of the graph of R, but reduces the fluctuations, making the general trend easier to see. Right? So the moving averages are in blue, right? Versus the original, and it maintains the general shape, but it reduces the fluctuations so that we can get a better sense of the trends. Okay, so the moving average smooths the data but maintains the general trend. Okay, that was interesting. All right, so let me see. I think we got a little bit more. We have a solid 30 minutes. All right. I'll take maybe like 20 minutes to kind of go through some homework associated with this section. Let me change my view to seamless. Yeah, I think that's what I'm. I'd like to add a page here. Okay, so I'm gonna let that chill. And then here, I'm just gonna get rid of this one, and this is what I want. Okay. Allow. Calculus. This is calculus. Let's see. We just did 4. I think it was 4-4. Right. Come on. There you go. I really like the topics of next week. Integration techniques with substitution and integration by parts. Like that's the culmination. Like I'm just glad we're gonna get a chance to talk about it. Let me see. Hey Google, give me a random number between 1 and 29. No. Nope. Yeah, I think she said 4. Okay, that's fine. All right, let's start off with question number 4. And I would like to move these guys around like that. All right. Come on. Okay. So it says, what section is this? This is a review. I'm going to skip that one. Let me graph it. It should be quick. So, like when x is 0, y is 2. Okay, you know what? I'm just gonna plot 3 points. We said 0, 2. Okay. When x is 1, we're at 3. So I'm just gonna plot. I'm dragging the second point to 1, 3. Okay. When x is negative 1, we're at 3. Boom. See. Right. So with graphing something like this, I felt like the simplest thing was just click on 3 points to get an image, and then move the points retroactively. And you can even click on where it says edit coordinates, and you can type them in. All right, and it should work. Okay. I think the next one was 6, so let's go ahead and do 6. This is a review as well. Graph and state the domain. So we have a reciprocal function that's been stretched vertically by a factor of 10. Let me see. So, like when x is 1, we should be at 10. So it can't be A, nor can it be C. I think B is wrong. The only one that looks close is D. Like with something like this, if you choose like some simple points for x to test, just plot the points real quick. The only one that's even close looks like it's D, so I'm going to go with that one. The domain, so the very left to the very right looks like it's all reals except 0. Okay, so we need something like this. Just oh. Trying to get to some stuff from today. This is simple. So basically, we want everything except 0. So, and it needs to be an interval notation. Let me just get rid of this. There we go. So if we want everything except 0, the far left is going to be negative infinity up to 0, union 0 to infinity and beyond. That was it? Okay, I thought we were going to ask for the range. Let's get our random number here. Come on. Generate. Let's go to question 21. Let's see, we said what, 28, 7, 6, 5, 4, 3, 2. 1 should be this one. That's 22. Okay, one more. Okay. Find the area of the region bounded by the graphs of the given points, of the given equations. So, okay, yeah, let's take some notes on this one. Come on. Okay. So this is question 21. This comes from section 4.4, question 32. Let's see. Find the area. One of them we have is 2x squared minus 5x plus 5. Another is x squared plus 7x minus 15, right? 15. Okay, so first, let's find the points of intersection for these two. So we're going to set them equal to each other and solve. So we have 2x squared minus 5x plus 5 equal, we want to set it equal to x squared plus 7x minus 15, okay? If we say the left minus the right, we're just going to subtract and move everything to the left. So we got 2x squared minus 5x plus 5 is going to be minus x squared minus 7x plus 15 equals 0. Okay. So then 2 minus 1 is 1. So there's an x squared that remains. Let me see. Negative 5 minus 7 is negative 12x. 5 plus 15 is 20. Can this be factored? The signs should both be negative. 5 and 4, 10 and 2. Right. So it looks like when x is 2 and 10, that's where these two graphs should meet. So to determine which is higher, because remember when we say one function minus the other, we need to say the top function minus the bottom function. So I'm just going to choose a number kind of in the middle. Let me see, that distance is what, 8, so 4. So let's choose when x is 6. When x is 6, if we plug them in, whichever one is higher, we're going to say that's the one that's on top. All right, I think that's safe. 6. Siri, what's 2 times 6 times 6 minus 5 times 6 plus 5?
2 times 6 times 6 minus 5 times 6 plus 5 is 47.
Okay. Siri, what's 6 times 6 plus 7 times 6 minus 15?
6 times 6 plus 7 times 6 minus 15 is 63.
Okay, so it looks like the second one is on top of the first one. Yeah, I think so. I'm going to go with that. So we're going to say the second function minus the first function, okay? So if we want the area between these guys, we're going to take the integral as x goes from 2 to 10. We're going to say the second function minus the first. So we're going to have this x squared plus 7x minus 15 minus 2x squared. What's the time? This is going to have to be the last one. 5 x, okay? Integral as x goes from 2 to 10. We're going to have what? Negative x squared plus 12x. That's not a 12. 12x minus 20 dx, right? So then if we integrate that, we're going to get a negative x cubed over 3. So plus, we know it's x squared, 6x squared, right? Minus 20x. We want to evaluate this as x goes from 2 to 10. So when we plug in 10, we're going to get negative 10 cubed over 3 plus 6 times 10 squared minus 20 times 10. We get an answer. We're going to say minus when we plug in 2. So negative 8 over 3 plus 6 times 2 squared minus 40. Let me just get all this on one line. And then expand it back. Okay. All right. The first one, what is that, 1,000 over 3? 600? 600 over 1, 1,800. Okay. 200. 200 over 1, 600. Minus, let's see, it looks like we have this 8 over 3. 4 times 6 is 24. 24 times 3, 72. Let me check it again. 24, 60 plus 12, 72. 72 over 3. 120. Okay. What is that, 200 over 3? because that's a negative 16 and 18 is 200 over 3. Let's see. 80, so 9. So then 64. Okay. So 120 minus 64. That's 100 minus 44. 60. 56. I think it's a negative 56. So double negative should be a plus 56. Man, hopefully I got that number right. 256 over 3. Let me see. 6, 12, 13. Simplify your answer. This isn't divisible by 3. 8 and 16. 8 and 8/3, 9. 16, 5, right? Okay, let's try 256 over 3. Hopefully that's right, because I got to get you guys out of here. 256 over 3. God is good, right? Because if that was wrong, that was going to be a pain to go back and try to find where do we make our mistake, right? A lot of that was like crunching numbers, so we could have used a calculator. Like honestly, we could have put this guy in a calculator, right? Let's just do it real quick, and I'll get you guys out of here. Right. So if we go to our y equals, I just want you to see this. All right. Oh, come on. Reload and refresh. Clear. Okay. So negative x squared plus 12x minus 20. Now, we don't always have this luxury of using a calculator, but, you know, whenever you can, it's nice to use it. All right. Math number 9. We want to evaluate the function that we just typed in terms of x as x goes from 2 to 10. And let's hit math as a fraction. We should get the same thing. Woohoo! All right, gentlemen. Are there any burning questions before we go our separate ways? Let me make a copy of this available. Send it to box. Spring. Come on, you can do it. I believe in you. Let's go. You can do it. Let me get rid of this. Hopefully that helps. Oh, okay, thank you. Traditional calculus notes updated daily. And this should be is correct. Okay. So when this bar finishes loading, you'll receive a copy of anything that you saw me writing. And if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. And next week will be the last of our new material, right? And then shortly thereafter, we'll be gearing up for exam 2, covering chapters 3 and 4. All right, gentlemen, enjoy your weekend. Get some rest, play hard, study hard, finish strong, you know, do what you need to do. All right, gentlemen, take care. See ya.
Have a good one.
Take care.